Hello everyone, myself Manisha Sawant. I am from Vidyadhir, Institute of Engineering and Technology. In last lecture, we learnt about limits in complex function. In today's lecture, we are going to learn about continuity in complex function. Continuity of complex function. A complex valued function f of z is said to be continuous at a point z is equal to z0 if f of z0 exists. It means function f of z is defined for z is equal to z0. Second condition is limit z tends to z0 f of z exists. Third condition is f of z tends to z0 f of z is equal to f of z0. Okay, if here we have three conditions. First condition is function is defined for z0. It means f of z0 is exist. Second condition is limit z tends to z0 f of z exist. Third condition is limit z tends to z0 f of z is equal to f of z0. It means limit, the value of limit and function at z0 are same. Okay, next is remark. F of z is equal to u of xy plus I of I into v of xy is continuous if and only if u of xy and v of xy are continuous. Okay, the function f of z is continuous if and only if u and v both are continuous. If one of these three conditions of continuity is not satisfied, f of z is discontinuous at z is equal to z0. Okay, it is compulsory to satisfy all of three conditions. Okay, it is compulsory for any function to satisfy all of three conditions for become continuous. Next is one example here. Determinant determine whether the function f of z is continuous at the origin. Okay, origin is the point 0, 0. We have f of z, we have given f of z is equal to x plus y all square upon x square plus y square. If z is not equal to 0 and 0 if z is equal to 0. Okay, limit z tends to 0 f of z is equal to limit z tends to 0. We put the value of f of z, x plus y all square upon x square plus y square. We know the condition for the continuous. Let z tends to 0 along the line y is equal to mx. We put value of y. Okay, y is equal to mx. The limit f of z is equal to limit y, z tends to 0 x plus mx all square upon x square plus m square x square. Okay, limit z, we take x as a common, okay, and cut from numerator and denominator, then we get limit z tends to 0 1 plus m whole square upon 1 plus m square is equal to, we put the limit of z tends to 0, it means 1 plus m whole square plus 1 plus m square. Since the limit depends on m, it takes different values along different paths. Okay, we can take any value of m, so different values of m, thus limit does not exist, hence f of z is not continuous at the origin. Next is, our next topic is differentiability of complex function. Okay, let w is equal to f of z be a continuous function. We have already learned, but what is continuous function? Let w is equal to f of z be a continuous function and z0 be a fixed point. Then f of z is said to be differentiable at z0 if limit z tends to z0 f of z minus f of z0 upon z minus z0. Okay, it is necessary condition for prove any function differentiable, okay, exist, and the derivative of f of z at z0 is denoted by f dash of z0 and is defined as f dash of z is equal to limit z tends to z0 f of z minus f of z0 upon z minus z0. It is definition of differentiable of differentiable. Okay, in another form we can write f of z f dash of z is equal to limit h tends to 0 f of z plus h minus f of z upon h. Here we have one example. Find the derivative of f of z is equal to 1 plus z upon 1 minus z by using the definition. Here now we show the definition at z is equal to 2. F of z is equal to 1 plus z upon 1 minus z. After z is equal to limit h tends to 0 f of z plus h minus f of z by h. At z is equal to 0, f dash of 2 is equal to, we put the value of z, which is z is equal to 2. We show the definition, we are using the definition, then we get f dash of z is equal to limit h tends to 0 f of z plus h minus f of z by h. We put the value of z is equal to 2, then we get f dash of 2 is equal to limit h tends to 0 f of 2 plus h minus f of 2 by h. Okay. Here we have f of z is equal to 1 plus z upon 1 minus z. So in place of z we have to put 1 plus z upon 1 minus z. In place of z we have to f of z, we put the value of f of z. Then we get, in place of z we have to put 2 plus h and f of 2. Okay, then we get 1 plus 2 plus h upon 1 minus 2 plus h minus 1 plus 2 upon 1 minus 2. Limit h tends to 0. 1 plus 2 means 3. 3 plus h upon 1 minus 2 means minus 1. Minus h plus minus 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 h minus 1 plus 3 2. 1 plus 2 is equal to 3 upon 1 minus 2, it means minus 1 upon h. Okay, we take LCM on in numerator, then we get 3 plus h minus 3h upon minus common 1 plus h into h. Okay, 3 cancel, plus 3 minus 3 cancel, h minus 3h, it means minus 2h upon 1 plus h into h. Okay, 2h cancel, then we get 2 upon 1 plus h. It means we put the limit h is equal to 0, then we get 2. Okay, now we are going to stop here for this lecture. In next lecture we are going to discuss about analytic function. Okay, analytic function in complex number. Thank you.